Hi, welcome everybody. As you can see, there's been a slight venue change. That should be okay as long as the T-Rex doesn't get me. Today, of course, is day 7 of CPR, and this episode is brought to you by the Greek letter pi. No explanation needed for that one. First thing I want to do today is talk about question number 3 from the impulse and momentum assignment. It was a pretty minor question, but I know there was no solution for it. Should have went over it before, so I'll go over it now. And it was basically asking you why whatever sport you're doing, basketball, soccer, volleyball, hockey, whatever sport you're doing, why following through is very important. And here's the deal with that one. Let's say, suppose you're chest passing a basketball, and of course you could chest pass a basketball just with that kind of motion, a very short, abbreviated motion. You can apply a lot of force that way. However, if you follow through and do something like that, well, then of course you're applying the same amount of force, but for a greater length of time. That means force multiplied by time, more impulse, and of course greater change in momentum. Okay, enough of that. Sorry about that. Hazards of working at home, I guess. Anyway, right now, what I want to talk about is angular momentum. Once again, that's angular momentum, and this is strictly for interest sake. This is not on your test or anything. It's just something that's kind of interesting to know a little bit about. If you take a university physics course, they'll get into this in more detail. But here's how angular momentum works. Of course, regular momentum is equal to mass times velocity, and angular momentum is the same thing as rotational momentum. Now, if you're rotating or spinning, okay, you're rotating or spinning through an angle. And of course, that's why rotational momentum is generally called angular momentum by physicists. Now, angular momentum, it depends on, first of all, how fast you're rotating. It depends on mass, and it also depends on how far the mass is away from the center of rotation. So let's do a quick little demonstration and see how this works. Okay, as you can see, I'm on a chair that's free to rotate, and right now, I've got a certain amount of mass, and the mass is a certain distance away from the center of rotation. Now, what do you think is going to happen as I'm rotating and I draw the mass in like this? Let's see if we can see what happens. Okay, hang on a second here. I don't want to get dizzy and pass out on video. Okay, so yeah, obviously, when I draw my arms and legs in like this, the mass is staying the same, but the distance that the mass is from the center of rotation, that's being reduced. Angular momentum has to be conserved. It has to stay the same, whether I'm like this or like this. But if I'm drawn in like this, okay, well, the distance the mass is from the center of rotation, that's going down. So the rate of angular rotation goes up. And if we want to exaggerate this a little bit, we can bring a couple dumbbells into this situation. Okay. Just before I do this, if I have a real bad wipeout, make sure you call 911. Thanks. As you can see, same kind of deal. You reduce the distance the mass is from the center of rotation, and the rate of rotation goes up. Okay, let me get rid of these. Oh, whoops, better not do that. That didn't work too well last time. Yeah, and of course you'll notice whenever figure skaters, whenever they take off to do a triple axel or a triple lutz or something like that, well, they want to rotate as fast as possible, and you notice that they have their legs crossed and their arms tucked in tight, like so. Okay, enough about angular momentum. And again, that's just for the heck of it, just for interest's sake, won't be on your test. Speaking of which, that's what you should be doing today. That should be the bulk of your efforts today, at least as far as physics is concerned. It's due Monday at 4 p.m. Make sure you email it to me. Tomorrow I'll post a video. We're going to start the new unit. And as far as details regarding the rest of the course are concerned, those should be available tomorrow too. Got to have a couple meetings with admin and make sure everything is squared away. Bye for now.